Welcome to the demo of the Consumer-Side Privacy and Usage Control plugin. In the first version, we showed how consumer organizations specify internal policies, define data processing workflows, and resolve conflicts between user intentions and internal policies. The latest version brings major enhancements in interoperability and collaboration, alignment with DPV and ODRL standards, improved conflict resolution, and new features for handling datasets, pricing, and energy constraints during workflow specification. As shown in the previous demo, the consumer dashboard, built upon good flows, allows organizations to define semantic models using the information model editor. It manages data types, purposes, roles, operations, and context types, among others, along with the underlying ontology. Class individuals form and hierarchies and/or hierarchies. For example, here's the data types graph. Blue lines denote there's a specialization relation, and red lines this part of inclusion relation. These hierarchies enable defining high-level rules to apply automatically across entities, avoiding exhaustive rule sets. Now, we've added the ability to import and align third-party ontologies with good flows, including those created on the provider side. Using Postman, we send ontology files and JSON mappings to the external ontology import endpoint. Our import mechanism supports subclassing hierarchical relations and multi-step ontology integration, boosting interoperability with other systems. Here's a mapping file example for DPV and ODRL. Each object includes a class's mappings property, linking source concepts to good flows classes, DPV purpose maps to purposes, data to data types, and so on. Namespace and namespace delimiter ensure entity references are correct. Subclassing determines whether the imported ontology forms the vocabulary associated with a class as subclasses or as class individuals. For DPV, subclassing is true. For ODRL, it's false, and additional properties manage translation to is a and is part of relations. Members of action and processing classes are added as individuals with specialization properties like included in and broader transitive. The response is a good flows information model aligned with DPV and ODRL. Here, derive is aligned to equivalent concepts via same as property. In Process Modeler, we define data processing workflows. In the previous version, these focused on consumer-owned resources. Now, workflows support additional Upcast-specific requirements, enabling third-party dataset imports, as well as pricing and energy constraints. Users declare datasets by dragging and dropping, and can access the resource specifications and ODRL policies that the dataset's usage must abide by. Alternatively, they can search connected marketplaces, right-click and select Add Dataset, inserts a node, then search by data type, name, or marketplace connected to the Resource Discovery plugin. Discover datasets include all available information. Here's a sample workflow. A training measurements dataset feeds a statistical analysis task, with the results being published. The intended purpose is commercial research. Users can also define constraints for the workflow, like the total energy footprint and the cost that is considered acceptable for implied processing and overall execution. The third-party dataset carries an ODRL policy containing a permission that allows a non-governmental organization with more than 200 employees, for the purpose of research and development, to partially analyze training measurements are using only burnt calories, exercise type and heart rate range contained therein, provided that the associated measurements will be first anonymized and that the processing will take place before 31st December 2025. It also contains a prohibition prohibiting a non-governmental organization Omicron of any size to analyze training measurements corresponding to recent training sessions performed after January 1, 2025 for the purpose of commercial research. In this case, the permission is more general, applying for the high-level research and development purpose, while the prohibition constitutes an exception to the permission for the more specific purpose commercial research. Selecting Verify Process Model validates workflows against internal and third-party policies. It checks and possibly re-engineers against organizational policies first, then validates compliance with third-party ODRL policies. The policy decision point API reasons over both types of policies. Full validation is covered in Work Package 3, but here we focus on conflict detection and resolution against third-party ODRL policies. In policy administration, we previously demonstrated access and usage control rules specification and explained their semantics. Here's a permission for commercial research, allowing NGOs to publish aggregated training measurements within the EU. Most good flows entities map directly to ODRL, actors to assignees, operations to actions, resources to targets, purposes, action and contextual constraints map to ODRL constraints. Good flows handles mandatory pre- and post-actions, directly mapped to ODRL duties and obligations. It also adds forbidden pre- and post-actions, extending ODRL with temporal constraints. Our ODRL adapter enables bidirectional translation, allowing the evaluation of intentions and requests against usage constraints. This enhances the Good Flows policy engine's interoperability and broader adoption in digital rights ecosystems. 2 endpoints handle conflict identification and resolution. 1, tailored for the consumer dashboard, validates workflows against third-party policies. For example, a request to perform statistical analysis on training measurements by an NGO for commercial research is checked against the previous ODRL policy. The adapter translates the policy to a Good Flows policy model ontology, and each rules are derived from rule propagation. The rules are propagated from research and development to more specific purposes: academic research, commercial research, scientific research and non-commercial research, and from analyze to perform statistical analysis. After conflict resolution among applicable rules and rule merging, compliant intentions are generated. The response comprises the conflict structure, containing the original intention, reference to the rules that lead to the result, and the updated intention, which apart from possibly changed properties of a given intention also contains the combined resources property, and the pre- and post-actions that should or should not be performed. In this case, it adds constraints on number of employees, processing deadlines, and resource refinements limiting processing to burnt calories, exercise type, and heart rate range for sessions before January 1, 2025. A pre-action has been added to the updated intention prescribing anonymization of the associated measurements before processing. Finally, original rule ID property declares that both rules defined in the given policy applied and were combined for the given intention. For academic research, the date restriction on training session doesn't apply, as the prohibition targets commercial research. The second endpoint processes ODRL requests and third-party policies independently of the consumer dashboard. For example, an ODRL request to perform statistical analysis on training measurements by an NGO for commercial research, when checked against the same ODRL policy, results in an updated request with an alternative permission. In this case, we see an extra modification. No conflict arises for Upcast perform statistical analysis, as it's a specialization of the DPV analyze operation. In this case, ODRL's implies predicate denotes concept specialization, improving explainability. Both endpoints support flexible purpose and flexible actor parameters, allowing compliance checks beyond the specified purpose or actor. For example, no compliant request may exist for marketing. But choosing flexible purpose results in updated intentions for all valid purposes, inheriting from DPV research and development. That concludes the demo of the consumer-side privacy and usage control plugin. Thank you for watching.